Hi there, this is Ayush from Lightscline, and today we are going to talk about how do you deal with large volumes of sensor data. For example, distributed fiber optic sensing. In distributed acoustic sensing, you have high frequency, so like 10,000 hertz. You also have a large number of channels, so that makes the data sets very high. So like we were dealing with zero point 0.4 TB, so like 400 GBs of data per day, that kind of volumes. Uh, so the first step that we need to do for machine learning is have a data set, but you cannot load all of that data set into the RAM. So you have to create logical chunks of the data. These logical chunks would be different from physical chunks. Uh, so we want to do something like lazy loading. You don't want to like load the data until it's actually necessary. So we create logical chunks of the data. The next step is events by their nature are very sparse. So like there's not a lot of events that you can see. There's not a lot of anomalies that you can see. So you need to do some kind of data augmentation for your machine learning models to actually learn. So in our case, we had like 17 events and we used augmentation to create like 1,000 events for that. And that was sufficient uh, for our machine learning models. Uh, Now, after that, you need smart sampling. So again, the number of samples and the channels are very high. You can downsample some of those things. So like if your frequency, if your event is in like 100 hertz frequency range, then you might follow the Nyquist theorem and then keep your fs is equal to 200 and stuff like that. But what we can do is we can actually train on even 5% of the data from each window. So this is Lightscline's proprietary smart sampling technology. It makes sure that you have the highest frequency information as well as the lowest frequency information kind of stuff, but just with 5% data kind of stuff. Yep. And then by this time, we were actually not loading any of the data, but now because we know what logical chunks to load, we can parallelly load them into the processors and then we can train models on that. Again, Lightscline can help you automate all of these steps. Uh, and to reiterate, before before loading the data, we were dealing with logical chunks. That's why it was very fast. And then after that, you actually train the models on the physical chunks. You also try to minimize the file reads and while you're doing augmentation and loading and stuff like that. So to avoid your IO bottlenecks and stuff like that. Uh, Thank you. Feel free to reach out to Lightscline if you have any kind of use cases.